Okay, so in this lesson, as we begin to study matter, we will look at the particle theory of matter and we will look at how we classify matter. So first off, the particle theory. What is a theory? A theory is, in essence, a proposition that is created by anyone, in essence, on how they think a phenomenon occurred or why they think something occurred. So it's a theory and it's not been proven by scientific evidence. So as more evidence is found, then theories can change over time. So more than 2,000 years ago, a Greek philosopher, not a scientist, named Democritus, suggested that matter was made up of tiny particles. So this theory has 5 different parts we will look at. The first is that all matter is made up of tiny particles. So in essence, a drop of water, so let's say is our little drop, if we look inside of it, it's going to have 30 million little particles. So this represents a water molecule. So imagine we had 30 quintillion. How do we read this number? This would be million, this would be billion, this would be trillion, quadrillion, quintillion. So 30 quintillion particles. So this would obviously go on and on and on. We could keep drawing these water molecules and there'd be 30 quintillion of them. Okay, part 2 says each substance has its own kind of particle, which is different from the particles of other substances. So as I showed you up here, this is water. So we're going to classify this today, how we come to this particular shape. I'll talk about this soon. So this is water. And this would be carbon dioxide. Carbon dioxide is what we breathe out. This would be carbon dioxide. Okay, and we'll make these red. Maybe you can figure out what this might be, this part of the compound, but we'll talk about that soon. So particles attract each other. So if they're far away, they can't have a lot of attraction, which is just kind of logical, right? So there'd be very small attraction. As they're closer together, that attraction is going to increase. So we'll represent this by a bigger arrow. And if they touch, however, and they will never touch, it will cause repulsion. So they're going to push away from each other. Particles will not touch. Okay? The next part of the particle theory is that particles are always moving. So we know, and we've studied this before, what particles are like in solids, liquids, and gases. So in a solid, they're really close together, as we know. And all they can do, because they're so tight, is they can vibrate. They can vibrate. In liquids, because they're a little bit further apart, they can move around each other. and fill in the spaces. And in gases, they move very quickly. Because they're so far apart and they want to take up the shape of their container. And lastly, if particles at a higher temperature move faster, they're given energy than particles at a lower temperature. So again, that movement in the solid would be as the temperature increased. As temperature increases, movement increases. Which causes the changes of state. So as the solid, the temperature increases in a solid, the particles are close, then we add more heat and then they become liquid. And then as you add more heat, then the particles are moving even faster and would become a gas. So changes of state. Because they are decreasing the forces of attraction between the particle. Okay, so that's the particle theory. So now let's take a look then at how we classify matter. So now that we have an idea of the particle theory of matter, let's classify matter. So matter is anything that has mass and occupies space. And a pure substance is matter that contains only one kind of particle. And a mixture is matter that contains two or more different types of particles. Not two or more different kinds of particles. So if we were to make a little chart of classification of matter, we could say matter's at the top, and we have pure substances and we have mixtures. So the first type we're going to look at are pure substances. So two types we will look at are elements and compounds. And elements are substances that cannot be broken down into simpler parts by chemical methods. So these are on the periodic table, right? These are the elements of the periodic table. And we'll be looking at that in chapter 5. So some examples could be hydrogen. There's over 100, so I'll just give you a couple. Oxygen. And one of my favorites, AU. Gold. AU, come over here. I love the element humor. If you have any good element jokes, please share them. And a compound is then a pure substance made of two or more different elements that are chemically combined. So, for example, we know this one off by most of us know water. It has a special name called dihydrogen monoxide that you'll learn in grade 10 how to name that. But I'll tell you. So now you can go home and say, Mom, Dad, I'd like a glass of dihydrogen monoxide, please. See what they say. We also have CO2, carbon dioxide, which we saw in the particle theory, but it has one carbon and two oxygens. And another one, and this is, we saw this in the biology unit, C6H12O6, glucose. So those are a few examples of different compounds. So it's also interesting to note that elements are made up of atoms and compounds are made up of molecules. Okay, so next we will look at mixtures. And two types we will look at are solutions and mechanical mixtures. A solution is a homogeneous mixture because it looks like it's only made up of one thing. It's uniform throughout, meaning it has one phase, and we have one substance dissolved into another. And some components of a solution are solute, and that is the substance that dissolves. So for example, that would be salt, table salt, for example. And the solvent is the substance which the solute dissolves in. And this would be, for example, water. So a few examples of solutions. Solid solutions, we can have solid solutions, liquid, and gas. So alloy metals, that's like a mixture, a solution of different metals mixed together, like bronze is an example of that. Oops, bronze. And Jello would be another solid solution. Liquids, we probably have the most knowledge of these type. Salt water would be an example. And gases, air. Air is a mixture of nitrogen, oxygen, and many other. Carbon dioxide, we could go on and on. But the biggest part is nitrogen, 78%. We talked about that, I think, in biology, and 21% is oxygen. So not very much of the rest of it makes up 1% of all the other gases. All right, so the other type are mechanical mixtures, and these are heterogeneous mixtures, and they look like they're made up of more than one substance. They're not uniform. They have more than one phase, and the particles do not mix together. So a few examples of these are pizza, Rocky Road ice cream, a toonie, so those are some examples of mixtures, and that's in essence how we classify matter. So I mentioned a couple of terms on the last page, and that was atoms that make up elements and molecules that make up compounds. So it was because scientists now call the particles in the particle theory atoms. So the atom is the smallest unit of an element, and every element is only made up of one kind of atom. And atoms join together in combinations. And when two or more join together, you form a molecule. So the molecule then is the simplest unit of a compound. So here's a couple examples. Here's our hydrogen atom, oxygen atom, and that was the one that was colored red in our other diagrams. and this was water. So water we know is H2O. So these are H's, and this is an O, H2O. Methane, that's the gas that you use to heat your home, is CH4. CH4, so in the middle we got a carbon, which I would typically color black. I gotta grab my black pen. And then this is hydrogen peroxide. So maybe you know that the hydrogen peroxide is what you use to clean your cuts or color your hair. And it's H2O2. So these would be two oxygens in the middle here. Okay. So how do we separate mixtures? So we separate them, there's a bunch of techniques. We're gonna look at three. One of them is filtration. So this is when we separate solids from liquids or gases. So for example, when we separate sand from water. Pretty simple to do because we could evaporate the water or we can filter it out. So when we filter, we would use, for example, what we could use, say we had a funnel. Inside we put some filter paper, and let's say this is our beaker. So the sand would stay in the filter and the water would come into the beaker. That's how filtration works. And you use filters, coffee filters, if you have that type of coffee machine at home where you put a coffee filter, you put your coffee in it, you run water through it, and then at the bottom the coffee comes through flavored, but the grinds stay in the filter paper. Distillation is another way we separate mixtures based on boiling points. So we can separate alcohol from water because they have different boiling points. So we would heat it up, the water would boil at 100 degrees, and different alcohols have different temperatures. So we would know one would be boiled off and the other one would remain. Lastly, there are magnets. So with magnets, we can attract the iron and steel and leave other objects behind. So if we could remove iron from dirt. Because the iron would be magnetic. Okay, so you can take a look at online to see what questions you should do. This is all the questions for the section, but you don't need to do all of them, so take a look at what you're asked to do in the lesson. And that's it. Have a good day.